Good.
Well, it's great to be invited here to talk at Epic and this thing, and thanks very much for inviting me. First of all, tell you a bit about me and PicSea. So I started off working with big underwater robots, taking pictures mainly for the University of Australia many years ago now, and moved back to the UK and started a company almost as a project for a few years to make underwater photographic imaging and photogrammetry much more accessible for many applications, so it can be used for more environmental and industrial applications. There's a lot of risks with taking pictures underwater with using conventional things like divers, and if you need remotely operated vessels you have to take the village with you, and involves a lot of people. So we're all about making it easy, removing the amount of skilled people that have to work in an environment that they don't want to, and making it easy and fast and safe. So it's a little video here, shows our vehicles being used. They're quite robust, can deploy many of them. They work on pre-programmed missions, slide down to the bottom of the sea, take some pictures, a few different ways to deploy, recover them, can use quite a good at the same time. The one-man portable, do reconstructions of things at the bottom of the sea, take a bunch of pictures, and I think that's it for that video. But yeah, so look at some of the build samples of data that I can share that we've got. This was looking at illegal dumping in a quarry that's quite close to us here. So we take pictures of things, create scale models that you can measure, and I like these pictures because people know what a car and a tire is. And I apologize if that's your car that was stolen in the images there as well. We also do environmental survey. So this was a 150 to 200 transect for siting an oyster farm on the west coast of Scotland here. We took 6 or 8 of these surveys in a few days last year for the University of Glasgow and the estate out there. That helped them site where they could put an oyster farm. We also have the remote operations, so our vehicles could be via these buoys operated completely from our office in Edinburgh. So this is the main picture there is operating in West Australia, the very North Islands of Scotland. We've also demonstrated this a few times across the Atlantic into Canada. And the boys can have cameras. We've got wind power versions. I mean, we're working on new projects that host our vehicles and with some project partners, and allow us to operate them perpetually remotely in big ocean environments. Well, so what do we want to talk about in photonics? I thought we'll give an overview. I'm going to make sure I buzz through this. Light, taking pictures underwater is hard, especially if you need your own light source. So if you're deep enough, not only then does the light have to get from the target to the camera, it has to go from your light source to the object back into the camera without illuminating the items or turbidity in the water. So especially with our smaller vehicles, is quite tricky. Speed restrictions, so we fly quite close, so really limits how fast we can move is how much light we can get and what exposure time we can use. So at the moment we can get to about 0.5 meter a second in favorable conditions, which is quite good. It's 1800 to 2400 square meters an hour, but we'd like to do more. Air-water interface is an interesting issue, that if you want to have a flat viewport, which is the easiest to manufacture and the less susceptible to damage, you're restricted in the angle of camera view that you can have because of the refractive index. I think Casey mentioned before, but yeah, we'd really like to be able to store and raw images and the auto gain, etc., that's used for often built into cameras, and those processes don't really work very well underwater. water absorbs red light the most, and it's visible spectra, and that disappears pretty quickly. We're always interested in integrating lower cost technologies. And one thing I'm particularly interested, if anybody has any motivation or technology that could help us, is working on panoptic or light field cameras in the use of removal of turbidity. I've done a bit of work about it in the past, and I'd like to continue that. And also anybody that's got interest in post-processing technology or techniques. A little bit of a video. This is the best thing illustrative video. This is our vehicles working at night around the pier. There's a lot of good developments really in through water communications. There's some commercial systems available that kind of do point to point, but there's a lot more to do, and I'd really like to find partners in that space. You're fighting things like power and distance. There's really cool opportunities, I think, for networking and active navigation. That's something we've been working on. I can't say too much about that, but something I've been working on. We'd like to hear from partners that are interested in the applications of that and also in developing it. Obviously, we're always fighting absorption. Yeah, and I think there's also opportunities for standardization. You know, it's happened in acoustic communications with the Janus standard. And it could be possibly part of or separate from Li-Fi standards that already exist. Always interested in off-the-shelf hardware that can be used in an unusual way, and also finding vehicles on the surface. It's quite easy to do at night, as you could see in that video, but in the daytime, if anybody can think of interesting optical techniques that we could use for locating vehicles on the surface, I'd be super happy to hear about that. And finally, sensing. I thought I'd put this up just to this is the thing we're always fighting, is the absorption spectra of water. In some ways, we're quite lucky that light does go through water. I guess otherwise our eyes wouldn't work too. But we evolved in the terrestrial domain, and we can still see things underwater to some extent. But red is and infrared doesn't work too well. But lots of cool sensors that exist on the surface, and if it's in the terrestrial domain, in air, do use the infrared spectrum. You know, optical flow cameras, laser ranging, time of flight cameras. You know, and really be good to find ways to implement those underwater. So if anybody has some ideas about how we could do that, be really interested to hear and put together a project around that. Obviously, we've mentioned that thermometers are used underwater, and other sensing applications and sensors that work in that could work in the domain too. Always interested in scale and reduction of cost. We do things at scale. You know, we produce vehicles, are starting to produce more vehicles in bigger numbers and reducing the cost. I mean, our vehicles cost about £20,000 for the full setup, I think, at the moment, and we're working on moving that down scale. So also great for research applications if anybody's interested. We're always interested in expanding applications and accessibility, and we work with a lot of companies doing research and development. So more than happy to hear about those opportunities. And I'd like to ask if anybody thinks there's anything I've missed in our applications, I think, as well.